All right, guys. So here we go. This is a question that's been giving you guys issues. So yeah, let's talk about why it's been giving us issues. So we obviously can't do direct substitution, right? Because we get 0/0. So we got to do something. So hopefully you guys know what's going on. We've done composite argument properties in pre-cal. Chop, what are you talking about? So remember when we were in pre-cal and we went over something like sine of A plus B, and we said that this was the same thing as sine A cosine B, and then we did plus cosine A sine B. Well, that's exactly the property that we're going to use, guys. That pi over 6 is like A, so that's like your pi over 6 right there, and that H is like your B. So we're going to use that, and then what other things are we going to use? So we're going to use these three properties. So let's see if we can figure this out. So we're going to use this property. We're going to write limit as x approaches 0 of sine happy face x over happy face x. So that happy face just means that the coefficient in front of the x have to be the same, guys. And so that's going to equal 1. The same is true for happy face x over sine happy face x. So what else? What other property are we going to use? So really, we're going to use this property as well. Limit as x approaches 0 of 1 minus cosine of happy face x over sad face x. So that happy face and sad face means that they can be different numbers. That's all it means. We can have different numbers, and this will always equal 0. Same thing is true. You don't have to have 1 minus. It could be cosine minus, right? So the same thing is true in limit as x approaches 0 of cosine happy face x minus 1 over sad face x. That is also true. So the only thing that you can't change, you can't have a number in front of that cosine, because then that's going to change your limit there. Same thing, you can't have a value or a number in front of that cosine or a variable. So there it is. So the happy face, sad face just means you can have any constant, and it will always be a 0. So all right, there we go. I think we are okay. I don't see any issue. Let's start. So first, let me change my marker to a red here. So here we go. I'm just using these properties right here, guys. So I'm going to write limit as h approaches 0. And so remember that pi over 6 is like A, that h is like B. So I'm just going to write sine of pi over 6. And then I'm going to write cosine of h. And then I'm going to write plus cosine of pi over 6. Let's see, sine of h. There we go. Oh, by the way, we still haven't finished. Minus, that minus is this minus. Sine of pi over 6. And then all this is divided by h. I think we're good. I don't see any issues right now. All right, so now we got to figure out what sine of pi over 6 and cosine of pi over 6 is. So remember from pre-cal or from geometry, whatever floats y'all's boat, whatever you remember from. So here it is. Here's my unit circle, and there's my pi over 6. And that coordinate is square root of 3 over 2, comma 1/2. Hopefully you remember that cosine is x and sine is y. And guys, don't be a robot. All this is coming from somewhere, right? So hopefully when you remember when you did in pre-cal, the unit circle has a radius of 1, right? So this horizontal displacement is x, and this vertical displacement is y, and then this is a 1. So that coordinate here is x comma y. And when you're doing SOHCAHTOA, when you're doing SOHCAHTOA, sine is opposite over hypotenuse. So sine of that angle, what angle? This angle right there. Sine of that angle is y divided by 1, so it's just y. And then cosine of that angle is x divided by 1, which is just x. So that's why your cosine is your x and your sine is your y. All right, so coming back, now let's continue with this. We're going to go limit as h approaches 0. And then sine of pi over 6, that is just square root of 3. Sine of pi over 6, that is just 1/2. So 1/2. And then, because remember, we said sine was a y value. Cosine of h plus, and then cosine of pi over 6, that's the square root of 3 over 2. So square root of 3 over 2. And then we're going to write sine of h. And then minus, again, sine of pi over 6. We said that was a 1/2. And all this is over h. All right, hopefully you guys are enjoying this so far. So here we go. Let's continue. So now what do we got next? Well, I'm gonna move this over here and then that over there, and it's in the same side, so the sign does not change. The polarity stays the same. Polarity just means the sign, right? Chav, why are we doing this? Because I want to know why you're doing that. Well, I can see that I already have a half right here. So if I move that 1/2 right to the middle here, I can see that I can start to try to get this right here, because I'm gonna start factoring out that 1/2, and when I factor out a half, I can see that I'm gonna get a 1. So here we go. I'm gonna write limit as h approaches 0, and I have 1/2 cosine h minus 1/2 plus square root of 3 over 2 sine h, and all this is over h. I don't see any issues. I think we're still okay. So here we go. Now what I'm saying, guys, is I'm going to do some grouping. So how am I going to group? So I'm going to group these two. Well, I already did, I guess. Well, I guess, okay. Here's what I'm going to do. I'm going to write limits, and I'm going to write as h approaches 0, and I'm going to write a giant parenthesis. And what I'm going to do is I'm going to break this up. So here's how I'm going to break it up. 1/2 cosine h minus 1/2 over h plus square root of 3 over 2 sine h over h. Okay, now what did I do? So guys, all I did was expand this. Notice that it says my denominators are both h's. I still get this right here if I were to group them both together and make one solid fraction. But I did this on purpose. Why did I do that? Well, I want you guys to notice this right here. It's going to start to look like this guy. And let me change my highlighter here to yellow. And then this guy right here is going to start to look like this guy. That's the property I'm going to use. So here we go. I'm going to write limit in front of both. I'm just using limit properties, guys. I'm not doing anything crazy. So here we go. And I'm going to factor out the half. So here's my half factored out. And I'm going to write the word limit as h approaches 0. And when I factor out that half, I'm going to have cosine h minus 1 over h. So hopefully you guys can see that now. And I'm going to write plus. That plus is this plus. And I'm going to write again. I'm going to write limit. Well, first I'm going to factor out that square root of 3 over 2. So here's that square root of 3 over 2. You don't have to factor it out. You can leave it inside that limit there. But I think it just makes life easier. Limit as h approaches 0 of sine h over h. So hopefully you can see now. Let's zoom out. So here we go. This right here that I'm putting in yellow, that correlates to this. Look, limit as h approaches 0 sine h over h. Limit as x approaches 0 sine x over x. As long as you have the same coefficient y do, that's 1h, and that's 1h as well. So there it is. And then if I look at the sky blue one, guys, look, this right here, the sky blue, that's this one. So again, cosine h minus 1, cosine happy face x minus 1 over sad face x. Well, it doesn't matter. You can have the same coefficient, cosine h minus 1 over h. We're good, guys. All right, so I think we're good. So here we go. I'm going to write 1/2 and then limit as h approaches 0, cosine h minus 1 over h. That's just going to be 0 plus square root of 3 over 2 times limit of h approaches 0 sine h over h. That's just going to be a 1. So there it is, guys. 1/2 times 0 is 0. Square root of 3 over 2 times 1. Square root of 3 over 2 times 1 is just square root of 3 over 2. So this is just square root of 3 over 2. So there it is. So this limit right here is nothing more than square root of 3 over 2. All right, guys. I hope that made sense. Give it a thumbs up if it made sense to you. I guess you can give it a thumbs down if you want. But I hope everything's making sense, guys. And yeah. All right. If you guys have questions, please feel free to swing by my room, or put something in the comments, and I'll try to get back to you guys. All right. Talk to you guys later. Bye.